Welcome to Turn Right Machine Works. My name is Keith, and today we're starting an old job. Back around the Mat Track Air and just before the What's in Your Box giveaway during that summer season there, we had a package and we opened this up at that time, and this is the gears and arm that need to be repaired for a small lathe. And Tyrell from Oklahoma sent this project in. And I apologize for how long it's been, but I'll give you a sweet deal on it anyway. I've got the blank material and the gear cutter over here. And we're going to get started in the lathe, and we're going to shape this out completely out of that piece of material there. And of course he gave us the mating gear, which this is actually a duplicate of diameter, because on a lathe where you have a spindle in the back gear, you actually have two gears that are opposing each other, and then you have a spinning shaft in there, and one goes through the drive chain and one goes straight through. And when you go through and then you lock the pin at the gears, which this actually has multiple holes here for a locking pin, then you're locking the quill solid, and then you're able to go ahead and undo or remove your chucks on the screw-on spindle. Okay. Sometimes, and actually I've seen this before, but a lot of times people are a little brutal on removing their chucks, and you know, they like to hit things with hammers and things like that. Gears do not take kindly to pounding on. That is the most case for this versus something getting caught in between the gears. Okay, and of course the bigger gear is going to be the weaker one as far as the leverage on the teeth there, because the pinion is closer to a pivot, center acting pivot there. Let's get back to where we're going here. So anyway, we're going to go ahead and we're going to create a brand new gear. At the same time, when I get ready to cut the teeth on that, and shortly after we cut the teeth on that gear, I'll be all set up, and I'm going to go ahead and do a braze repair and then cut the teeth in on this, so that this is actually a repaired gear. Now, because this is on a spindle, and most of the time it's not your choice, because there's been wear on this gear depending on how much it's been used. And you go and you you can time the teeth and you can get them really close. Usually what the case is if you can, and you can do all the gears at the same time, is go ahead and take just a slight bit more of a depth into them, adjusting so that your backlash remains the same. But then you can get away from having a new, what it is not so much that it's high, but it's new, so the pitch and the radius and all the working. All right, I want to bring in just a quickie here let's just get some of the gear terminology out of the way. And we see that the tooth is broken off down here in the root, and the root is in the lower section of the gear teeth. The top of the tooth is the land, and between the land and the root is a pitch line. The pitch line is center of the height of the tooth. Anything above that center line is called the addendum, and everything below that line, from center down to the root, is the dedendum. Those are the two terminologies of the working surface of the tooth. As teeth roll into each other, they're not just making contact at that split line, they are moving in, and they are actually sliding against each other, and that is the working surface of a gear. The middle pitch line, that material has not been worn off on the new teeth that you've got, so when it comes around, it gives you a little bit of a noise difference. The load is different. The backlash is changed from open gears, the old gears and the new gears and everything else like that. Now, if you're on a drive train, a feed train, and everything else down where things are a little bit slower and not so much noticeable directly to the spindle, it's usually a non-noticeable repair on your machining of your cut. sometimes when you do one on the main drive gear, you will actually see that finish in your cut, because the spindle will have a variation every time it comes around, so you're going to have lines that will parallel on your shaft. Just from past experience, I had a little 9-inch south bend, I did a spindle bearing and things, and I mean I fussed with it and fussed with it. I mean, it was my own gig, and I can, so I'm actually doing this to show the repair of the teeth, not that I would say, hey Terrell, put this one in, and let's make you a new one, and then you'll get in there. All right, the other repair, and in fact this has been brazed before, and I really haven't set this up on, pulled this pin out and put this on a surface plate to see if all of these machine surfaces are all been kept in line. And there's going to be a third one out here, and these things really need to be all parallel, because this is your gear arm on the back that holds all of your adjusting feed gears. All right, so we're going to be playing with that, and that's going to be another braze repair, and I'll probably braze that up the same time I do on these teeth here. All right, so I'm going to go ahead and get you positioned around here so you can be with me on the lathe first, and we're going to get started. All right, we're getting ready to put this part, this blank, in the lathe here to start turning this part. And we have about 5/8 of an inch to come off the radius, and probably half of the thickness of the slug here. Of course, we have saw cut on both sides. They need to be faced anyway, but we need to rough down the OD and the thickness and get a bore established to run this on an arbor. We will probably also come in and relieve all of this and get it ready for the mill, because we have 3 holes here, and then these are balancing holes for when the whole thing's all together. We got to put those in there, because that's not to balance this gear out, it's to balance this gear plus the attachment that swings around with this gear. There's a pull pin here and a couple arms right here, and that locks it into back gear, or freewheels it from the main spindle. The first thing I'm going to do is I'm going to go ahead and pull off these jaws, and then we'll have just a little stubby jaw sticking out that we'll be able to do our machine work in the roughing phase. So we should be able to, and we're gonna check it. If we can maintain the thickness and a nice comfortable bore in there to mount on an arbor, then we'll do that machining, and then we will turn an arbor to drive this, and we'll turn it between centers and finish the OD before we do the gears. All right. We're just looking back here at the back, and we can see a couple hollows and a couple tight spots, so we know that this is just a saw cut across both sides here. The jaws stick out here a little bit, so you have a certain amount of caution that you have to play with when you bring your carriage up to this area right here to do some machining. So I always make sure that my tool bit and everything else is out ahead of my carriage, so that I'm not going to be creating a crash down in here. Also, I want to go ahead and try to drape a cloth in here so that I can catch this cast material. Now I can turn this thing up and really let the stuff fly all over, but I usually turn cast a little bit slower, and I try to take bigger bites so that I've got chips that come off as far as the amount of volume and lay down into the cloth area to where I can just grab it like a knapsack and do away with it. or save it, crumble it, and go put it in a flower bed. Alright, I just wanted to just double check. Get some oil under there. Alright, now we want to come in here. We come in as close as we can, rotate it by hand, just make sure, and we are going to be rotating in that direction right there. We don't want to spin backwards. We got plenty of clearance. I got almost 2 fingers down, well, a finger and a half down there. That's good. Alright, our reverse. Okay, we're going to set 0 as far as I travel in. Alright, let's see if we can lay a rag down in here so that we can catch our debris. Alright, we're feeding in the right direction. Now let's just go in here because we're going to spot it in the middle, and we're going to take a little bit in and to the center, and we're just going to feed it in. And what I'm looking for is lining up, and we're actually a little bit high. I'm going to grab a tool bit to stick in here. Okay. Now I can adjust my height off of there because this surface down here is too low. Alright, so we loosen this up and we just stare down here real quick because we're within like a 16th of an inch. Touch more. Okay, close enough. That's the saw cut sound. Okay, that's 100 thousandths on the depth. There we go. Pretty much all of that spray is staying right down in there. seems to drag when you get close to the center. Alright, I'm going to probably take one light skim cut now and then come in and catch the OD down to the diameter or close to the diameter of the gear. Because I want to be able to turn this around and be actually holding on that diameter and get rid of the material on this side and then come in for a bore. And hopefully we can maintain a parallel width to the gear. We're going to try it. We're going to attempt that in the 3 jaw, so we don't have to make a special setup just to go ahead and set up to create a arbor mounting bore, which will be the finished bore as well. We're going to make the arbor fit this gear and the gear we're making. I want to check that diameter, and that's our 0 still looks good there. Okay. About 100 in there. I'm going to slow down the feed a little bit just because we're coarser in the feed and longitudinal than we are coming into the side or facing. These chips bounce a little bit this way because they're hitting the jaws as they come around. So they do bounce up. We can stay back out of the way and watch our travel dial. To go 20. Okay, that's close enough. Let's see, we're about 700 there, and there's like 550 left, so we'll be able to turn this around and bring it up to there. We could sneak up into here a little closer, but we're going to get it closer to depth. We got about 5 inches, and this is 6. So we now have about a ½ inch take off. Give it another 100. Take it at 100 at a time. Okay, I get about 700 here, and the width of this is just about 700. I can feel it a little bit proud. I know that the jaws only stick out about 450, so we can be holding it out here. But I think I want to go ahead and take. Let's see, we got about 60 thousandths left there. I'm gonna grab some more of that face in, so I have just a little bit more proud than I am right now. There's 25. I'm just cranking this in by hand. Alright, we're about 725, and we're close enough there. That's, you know, it's got about 25,000 more there. Alright, we're going to go ahead and take the vacuum. We're going to suck some of this stuff up before we actually try dismounting and turning this thing around. I actually want to go ahead and break that with a file. Okay, we've changed our cloth, got it all back in here, blew this down. We want to go ahead and we want to break this edge right here. Now, the jaws are sticking out. You see me reach over the jaws this way for a lot. You see me. When they're sticking out like this, I do not do that. And I just don't want to get caught in it. Okay, take my file. This is usually my corner burn. It's kind of like junked up. But I take it, just slowly roll it, keep it parallel so that I'm not getting the back of the file caught in there. Cast rolls over pretty easy. Takes the burr off. There's a slight little bit of radius on there now. Alright, now we're ready to turn this thing around. One little quick shot of air, and we'll also blow behind it. Now the jaw is going to come in about 5/8 of an inch from the outside now. Okay. Looks like we're nice and tight against there. We'll give an eyeball as we're turning it. Now we should be able to go ahead and face off so we get to our thickness. And then deburr that edge. Because the width, this gear, is actually narrower than what's left here. So we're going to be facing all of that off. Okay, here we go. I think we changed our direction. Our feeds, we increased our feed. Okay, we're good to go. Come in. Before we get going, I like to tuck this down in here. It sort of gives a little bed, little area for those chips to go in, and kind of make sure that that doesn't get caught. Okay. Count of thousands. There we go. Okay, we got about 100 thousandths left there, and that's about what our next cut is going to be. And we will still have more than enough because that's like 1/8 of an inch out there. Alright, so let's go ahead and take another 100 here. This thin razor edge right here will probably grab it, break it, and fly off of there when it gets down to the other diameter. It's about 1/8 of an inch away from meeting the diameter right now. At a 16th. Looks like it's matching the diameter now. So we finished, we just pulled out a little bit so we could get in here. And it is paper thin and it's right at there. It's hardly even raised up an area, but I'm going to go ahead and pull it off, and it's probably going to break off at each one of these little folds or wrinkles, and that's what it seems to be doing. I just don't want it flying and catching. All right. It feels like we got I don't know, probably 30 thousandths. what did I say, 30 thousandths? Oh, okay, let's just take in, this is like 690 or a couple thousandths under. 690, and this might have a little bit of a raise, but 725, so it wasn't too far off. So it's about 35 thousandths. All right, right now I'm just gonna take 20. Just so I know I'm leaving just a little bit on there. Alright, after this we're going to go ahead and we're going to work the hole through the center. It's just a starter drill that I'm going to put center hole in here so we can go through with a larger taper shank drill bit. Get us out there close. The finished bore is supposed to be right around 1.25 inches. Okay, this is just 1 1/8 inch drill bit here. Alright, now we're going to set up a boring bit so we can come in and bore that right to size. Alright, we got a fresh blanket here. We vacuumed up our chips, cleaned up everything we got. Got my CNMP here, and we're going to go ahead, we're going to kiss off that corner right there, and then we're going to set this up for a small boring head, or a boring bar, to come in and create the right size bore. And then we're going to come out here and we're going to go ahead and set up a tool bit. We're going to get a radius gauges. We're going to check this radius in here so that we can form tool this drop in here, relief on this side here. Since we're in here close, no need to get a file busy in this area right here just to break that edge for right now. We can play with these when we're out here on a mandrel running between centers. Alright, we'll get some speed feeds set up here, and we're going to probably put a dashboard gauge up here as well.